Hello everyone, in this video I'm going to explain you about smallest index with digits sum equal to index. So this is basically a contest problem and it was in weekly contest 450, and this is the first question there. So it says you are given an integer array nums. You've given integer array nums and return the smallest index I such that the sum of digits of nums of I equals to I. Okay, if no such index exists, return minus 1. So basically what they're saying is, see, let's understand with the example. Nums they've given 135, and if you see the sum of it digit is 1, but its index is 0, because in array index starts from 0. So this is 0, this is 1, this is 2. Index 0, 1, 2. But its sum is 1. So 0 not equals to 1, which is why this is not correct. And this one is index 1, okay, but its sum is 3. So index 1 not equals to sum 3. And now let's come to this one. Now here the index is 2 and sum is also 2. So in that case we'll have to return the index. They've given return I. So we are returning 2. See, also in explanation they've given for nums of 2 equals to 2, the sum of digit 2 which is equal to index 2, thus output is 2. Now let's understand second example. So they have given 1, 10 and 11. So this is index 0, this is index 1 and this is index 2. So index 0 and its sum is 1. So it is not equals. But if you see here, digits 1 plus 0 is 1 and its index is also 1. So we need to return 1. So they have given for nums of 1, 10, the sum of digit is 1 plus 0 is equal to 1, which is equals to I. And for sum 2 also, this one also if you see, the sum of digit is 1 plus 1, which is 2, which is equals to index I equals to 2. But in question they have asked you'll have to return the smallest. So whenever you while iterating from left to right, if you happen to get the first time that index only, you'll have to return it. So that is basically like, since index 1 is smallest, the output is 1. And in this case if you see, this is index 0 but sum is 1, this is index 1 but sum is 2, this is index 2 but sum is 3. So we did not get anything. So in that case we'll have to return minus 1. So I think pretty much you got the problem. What I'll be doing is I'll be taking n equals to nums, or let me just use for each loop. For int nums, okay, int temporary num, I'll take one variable temp num equals or let me just take num only. One variable will take sum is equals to 0. Basically we're counting the sum of the digits of this particular num. So while num sum plus equals to num modulo 10. If you are doing modulo, let's say 10 modulo 10 is 0. So for we got this element, and then we'll be dividing num divided by 10, num divided by equals to 10. So if you do 10 by 10, which is 1, so next time num will be 1, and it will enter into this loop, and 1 modulo 10 is again 1. So sum will add up to 0 plus 1 is equals to 1, and num will be 1 divided by 10 equals to 0. So in that case 4 loop will be coming out of this loop. But here once we come out of the loop, so we need to check if sum equals to index. Okay, if we want to take index, so we'll have to use this only. What do we say? Normal loop, I less than nums dot size I plus plus, and we'll take one variable num is equals to nums of I. Okay, so if it happens to be sum equals to I, basically this 0th index equals to sum of 0th elements, sum of digits of 0th element. So in that case we'll have to return I. Else if we happen to be we did not find anything, in that case we need to return minus 1. Now let me run and let me submit. Yeah, got submitted. So in this way you can solve this. And if you analyze the time complexity of this algorithm, so it is O of n, but this loop will be executed at max, since this is integer. So integers can be represented in 32 bits, so this loop will be executed at max 32 times. So you can say 32 into n, and which is also basically n only. And space complexity we can say 0, I mean O of 1. We are not using any space. So yeah, thank you guys.